So we know how to solve a quadratic equation if we can factor the polynomial, because then if the product of two or more factors is 0, one of those factors has to be 0. Now we are going to also look today at another option, because sometimes when we go to solve, we know the factoring is not an option. Okay, now of course it would be with this polynomial. If I subtracted 4 from both sides, we could look at x squared minus 4 equals 0. Say, well, there is a difference of 2 squares. And so it would factor x plus 2 times x minus 2. And then setting each of those factors equal to 0 and solving for x would give us our two solutions. We know with x squared there's always two solutions. And those solutions would be negative 2 and positive 2. So honestly, if I saw this equation, I would probably still take this path just because that's habit to factor if I can factor. But maybe I have something like x squared equals 5, or x squared equals 12, or something that doesn't factor if I set it equal to 0. So let's pretend like we're in that situation there. Now, if we over here in the margin go back to what we just finished in the last chapter, if I had an equation and it had a square root in it, and we were trying to solve that equation for x, we said, well, I can get rid of a square root by squaring both sides of that equation. And then when I square a square root, because this power matches that root, all that I have is the stuff underneath. And so we would know x equals 9. Okay. So the kind of inverse, I'm going to use the word operations, are a square root and squaring something. Which means if I'm looking at an equation like this, I can go in reverse. I can say it's already squared and I want to unsquare it, if that's an actual phrase or word. Okay. And so when I take the square root of 4, I'm going to not get 4 anymore, but I'm going to get 2. But I have to be careful right here. When I have the square root of x squared, I know that's equal to x, but I also know that I have to give a positive answer there, which means I need absolute values around that x. And then I know the absolute value of x equals 2 has two solutions. We set stuff inside equal to 2 and stuff inside equal to negative 2. Okay, so by putting the square root into the problem, I have to understand that officially these things are here, and that's where my two solutions are going to come from. Okay, I'm going to write this down one more time. Okay, so if we are solving for x and we want to use square roots to do that, if you like this path that I took right here, feel free to use it every time. Okay. But if you'd rather, I didn't leave myself enough room. Okay, if you are the person that puts the square root into the problem yourself, then instead of writing the absolute value step in there, you can call the square root of x squared just plain old x, as long as you put a little plus or minus out in front of the square root on the right side. That means positive 2 and negative 2 are the two solutions for that equation. So maybe let's keep them small for a little bit. Maybe I have x squared equals 12. I say if I just have x squareds or some expression in x squared equal to a number, okay, that's the part I hadn't said out loud yet, x squared and a number, x squared and a number, then I can take the square root of both sides to get rid of that squared term. Now, remember, if I'm the one that puts the square root into the problem myself, then I have to put the plus or minus there. So then I can say the square root of x squared is just x. And the square root of 12, if that were to simplify, like our 4 simplified on the other page to be 2, 12 under the square root cleans up to be 2 times the square root of 3, because there's two 2's and a 3 under here. Understand that the plus or minus goes out in front of all of that stuff, not in between it. Okay, not here. But the square root of 12 is 2 times the square root of 3. Okay, and then the plus or minus goes out in front of that. We said x squared equals the number works, but also if I have some expression in x, whoa, right off the page, squared equals a number. Okay, I can still use my square roots to keep track of what's going on with my time, but I can use square roots to help me solve this equation, and that'll be the shortest path. If I want to get rid of the squared, I can take the square root of both sides. If I'm the person that puts the square root into the problem myself, then I have to put plus or minus so I can keep track of both cases. The square root of x plus 3 squared is equal to just plain old x plus 3. If I want to simplify the square root of 20, I can break it down, and there's two 2's and a 5. So the 2 gets to come out from under, and my plus or minus is going to go out in front. Okay. Now, I haven't solved for x yet. I'm not all the way done here. I want to get the x by itself, so I can unhook the 3 by subtracting 3 from both sides. You can put your minus 3 at the end if you'd like. I in the book will both most often times put it out in front. But we have negative 3, we have our plus or minus, 2 times the square root of 5. Now 3 and 2 square root of 5 are not like terms, which means I can't combine them together into a single term. So this is the best I can do. If I in my calculator take negative 3 and add 2 times the square root of 5, that will be a solution to this equation. If I take negative 3 minus 2 times the square root of 5, that will be the other solution to this equation. Okay. Okay, let's do one more. Maybe we have x minus 2 squared equals 50. Okay. If I have x or an expression in x squared equal to a number, and this has to be a constant value. If this was a 50x, this was a 20x, I can't do that because I can't use square roots, because I don't ever want to hide an x under a square root. But if I have stuff squared equals a number, I can undo the squared by taking the square root of both sides. If I'm the person that puts the square root into the problem myself, then I need to put plus or minus out in front to take care of both situations. So on the left, the square root of something squared just leaves that something. On the right side, square root of 50, I have 5 squared and a 2, so the 5 can come out and the 2 is stuck underneath. The plus or minus goes out in front of all of that. It goes out in front of the product, not in between. Then if I want to get the x all by itself, I can add 2 to both sides, getting x equals 2 plus or minus 5 times the square root of 2. Here are my two solutions. Okay. I'm going to put another 1 or 2 up on the next page. Then you guys can pause the video and work them out, and then turn it back on and see if you're right, and then that's about as long as I need to go. Here are your 2 examples. Pause the video. When you're done, turn it back on. See how you do. On the left one, we take the square root. Don't forget your plus or minus. On the left, we just have x minus 6. On the right, what we're going to find out with our quadratic equations is sometimes our solutions are complex numbers. That's why we had to learn how to deal with those i's and those negative numbers under the square root. So when I comes out from the negative sign, the 4 is 2 squared, so it comes out, and the 7 is stuck underneath. Adding 6 to both sides gives us the stuff in the circle. On this one, if we take the square root of both sides, we get 2x plus 1 on the left. Square root of 48 simplifies to be 4 times the square root of 3. Okay, this one has 2 steps to solve for x. The first one is to subtract 1, and then the next one is to divide everything by 2. And I'm going to cheat and do like this here. We always need to make sure this fraction is reduced all the way, and it is. Remember, we cannot reduce the 4 and the 2 correctly because you can't ever cancel across a plus sign or a minus sign, which means it's just fine the way it is. Okay, practice some of these using square roots. Next video will be a different method.